Okay, so the last gas law that we're doing is the ideal gas law, and we saved it for last because it's a culmination of all the gas laws and it combines the number of moles. Now it looks fairly simple, but it can be derived from the combined gas law, and it does have all the other gas laws in it. The thing about the ideal gas law, though, compared to the combined gas law, is that the ideal gas law has moles in it. And you are looking for the gas conditions of a fixed number of moles of particles in the gas. In the combined gas law, the number of particles doesn't change, but you are changing the conditions of the gas. In other words, you're expanding it or cooling it, pressurizing it. In the ideal gas law, we're looking for the conditions of a particular number of particles at a set of other conditions. And I'll show you what I mean by that in a minute. Okay, so basically the bottom line is the ideal gas law relates the physical dimensions of the gas, pressure, volume, temperature, to the number of moles of that gas. It is an extension of the combined gas law because we can write PV divided by T, and if we write that in a different format, you can say that PV equals some constant, we'll call it CON times T, right? We're just taking the T and moving it to the other side of the equation, right? And it's this constant that has this in it. That is the constant. So there's your quick derivation of how the ideal gas law comes out of the combined gas law. Now, the only thing that we have to remember is these variables, PV and T, are all the same from before, pressure, volume, and temperature, but now we are adding this new variable, the number of moles. Okay? So let's see how that works in the next slide. Okay, so when you look at the ideal gas law, all of the parameters that we've talked about before, PV and T, are all the same things. They're pressure, volume, and temperature. The new thing that we are asking, or the new two things that we're involving, are this N value and this R value. Now the N value, the N, is the number of moles of a gas. If it's in grams, you'd have to convert to moles. But for this particular activity, for today, I'm not making you convert anything into moles. Right? So, but you should know how to do that. And then the last thing we need to understand is this R value. And the R is the universal gas constant. Now the key thing here is the units of the gas constant must match the pressure units that we are given. So if we are given atmospheres, the gas constant has to be the one that we use with the atmospheres in the units. And you'll see what I mean by that in a minute. One last thing. We have to make sure everything is in liters for the ideal gas law. Whereas before, if we were going from 700 milliliters to 900 milliliters, we didn't have to convert because we're keeping the same unit. But in this case, the liters is necessary because it's the unit of the gas constant. So they have to be consistent. Like I said, consistency. So you either have to change the units in the gas constant or you have to change the units in the volume. And it's easier to change the units in the volume. Okay, as said before, the universal gas constant is very specific to the pressure units that you're using. So this is very specific. So if you're using atmospheres, this is your R value. If you're using kPa, this is your R value. Torr. Okay? Now, I am not making you memorize these. And besides, the only ones we're really going to be working with are these two. But just be assured that if you were ever giving another problem using these types of units, you'd have to look up or be given the other unit for the R value. But for our class, we're only using these, and you must match whatever the unit of pressure is in the problem, that's the one you select. So if you're in atmospheres, you select this R value. If you're in kPa, you select this R value. These numbers will always be given to you on the top of a worksheet or a test or anything like that. Solving ideal gas problems are exactly the same as solving combined gas law problems. The only difference is you must make sure that you select the correct gas law problem to use for your particular application. And as I said before, if you're using moles and not changing the conditions of the gas, then you use the ideal gas problem law equation. If you're changing the conditions of the gas, in other words, you're changing its pressure, you're decreasing its volume, you're increasing its temperature, whatever, then you use the combined gas law problem. So on today's worksheet, it's going to be a mixture of ideal gas and combined gas law problems. So if you've identified it to be an ideal gas law problem, you do the same thing as you did before. Identify and assign your variables. And then here's the key. You must select the appropriate gas constant based on your pressure units. So you look at your pressure units in your problem. Okay, it's in atmospheres, so I got to select the R value that has the word atmospheres in it. Insert the variables and then complete the math. So let's see how it's done on the next page. Okay, so if you are following along on the video here and you take out your worksheet that you're due today, that was due as part of this assignment, this example problem is very similar to problem number 1 on your worksheet, right? You're going to have different numbers, but it's basically the same question. I'm asking you to find the pressure of a gas given these conditions, right? So the first thing we're going to identify is what is the equation that we need, right? So we're going to look at this real quick and we're going to see what is the pressure in atmospheres of 34.5 liters, that's a volume, 5.6 moles. So that gives it away. That says that there are moles involved, and I don't see any other parameter changing. It doesn't say what is the new pressure or I change the volume from this to this. So moles has been involved and there's no changes, so we're going to assume that this is the ideal gas law, which is PV equals nRT. All right, so now that we've got that, now we're going to go through and assign our variables. So it says, what is the pressure in atmospheres? So that, it's asking for the pressure, so that's my question mark. So that's what we're going to try to find, right? And then of 34 liters, notice it's in liters, but that would be my V, 5.6 moles of nitrogen, so that's my N. And then gas, it is at 50 degrees C, so this is my T. Now this T is in degrees C. We need to convert to T to K. All right, so that's something we got to do, right? So the only thing we don't know right now is this R value. And so we go back to our pressure thing. It says, what is the pressure? So we're finding the pressure, but it asked me for it in ATM. So our R value must be in ATM. So it has to have a unit of ATM. So when we go look on our sheet, at the top of our sheet, we should find the R value that has the word ATM in it, or the unit ATM in it. Okay, so now that we've basically assigned the variables, here they are. I've converted the degree C to that, and I assigned my R value. That's what I got from there. And now I just write the equation. There it is, and that's PV equals nRT. So here's my N, here's my R, there's my T. P we don't know, that's the question mark, and then this is my V. Sorry, that's my V. And then on the next page we'll have the answer. Okay, so I've got my final answer here, and because it was asking for pressure in atmospheres, there's my final atmosphere thing. And remember, atmospheres here means that I have to match the R value. This is my R value, and notice that it has atmospheres and it matches that. Right? Everything else is just plug and play again. Right? So there you go. that's pretty much how you do problem 1 on your worksheet. You just have to put in different numbers now, but the setup is exactly the same. Okay, so if you're following along with your worksheet, this is a prime example of how to do problem 2 on your worksheet. So problem 2 on your worksheet asks for the temperature in degrees C of a gas at certain conditions. This is a very similar problem to that. We're going to do this problem, and then you can model it for your worksheet problem. So again, all I'm doing is I got to make sure that I'm using the right formula here. So this one says, what is the temperature in degrees C? Okay, so now I have to go into K and then convert back. That's what it's telling me. Of this many liters of 1.6 moles of CO2 gas. So I see the word moles. I don't see anything changing. So therefore, I'm going to use the ideal gas law. So I'm going to say this is the ideal gas law again. And so I know I need to go PV equals nRT. Now the thing I have to select now is this R value because I know everything else, right? So the R equals, and what does it have to equal? Well, we look back on our problem and it says, what is the temperature, blah, 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 and then it says gas that is at 39 kPa. So the pressure units for the R value are kPa. So we need to find the one that has kPa in it. So once we do that, we know that that's 8.314 kPa liters mole degree Kelvin. So that's the R value. So now we're going to set it up on the next page. Okay, so there's the problem. There's the formula we're using. These are all the values. Remember, we're in K. There's my R value that we selected. We solve using this. Here's my general solve. Right, so this is, we're solving for it, and then we just have to isolate the t here to get it to solve the problem, and we'll do that on the next page. Okay, so we put in all the variables, and I isolated my t, I solved my equation, and I get this. So the t is equal to 70.9 K, and that would be fine if it was asking you for the temperature, but it's asking for the temperature in degrees C, so we've got to convert it. So remember that in order to convert, K equals 273 plus degrees C, so C equals K minus 273. So when we do that, we get 70.9 minus 273, which gives us this. And so that's how we got that. And that's pretty much it. There's really not much to the ideal gas law. It's probably the simplest of the gas laws to understand. You're just basically calculating the variables of a fixed amount of gas at conditions that are predefined. So that's it. You just may have to make sure that you're using the right gas law for the right conditions. So if you have, again, if you have changing conditions of your gas, you use the combined gas law. If you have moles specify and no changing conditions, you use the ideal gas law.